We're looking at solving systems of linear equations and problem solving. So this is a pretty tough chunk of content here. So we're gonna take a look at quite a few problems of multiple different types of scenarios that could pop up, whether it be distance problems, whether it be mixture problems and money mixture problems, like a lot of different scenarios in this video here. So the first one, in a particular country, the annual availability of head lettuce has been decreasing in recent years, when the availability of leaf lettuce has been increasing. For the 2000 through 2019, the function given here approximates the annual country's per capita availability of head lettuce in pounds, and the function given here approximates the annual country's per capita availability of leaf lettuce in pounds. For both functions, x is the number of years after 2000. So a part of this question got cut off, which I'm realizing now. But what they want us to do is they want us to see when are these two pieces of information going to be equal to one another. So we have these two functions, y equals negative 0.51x plus 22.79. And then we have another function, y equals 0.3x plus 13.4. So the question should have had a line of when do these two functions equal one another, or when does the production equal to one another, something like that. I don't know why it got cut off, but we just want to set these two equal to one another because we have these two functions of y, so we could just use substitution and then just solve. So I'm going to say 0.3x plus 13.4 is equal to negative 0.51x plus 22.79. And then we just solve for x. So I'm going to add 0.51x over. So it's going to give me 0.81x plus 13.4 equals 22.79. Solve for x. I'm going to subtract 13.4. So I get 0.81x equals 22.79 minus 13.4 is 9.39. Divide by 0.81 is 11.59. So 11.59 is x. So then that means after 11.6 years that these will be equal. So we can say about 20, somewhere in the 2011 era, because it is x is the number of years after 2000. We got an x value of 11.59. So that put us right in about 2011, somewhere in June or July of 2011. So say 2011.5 or 0.6. Yeah, so there should have been a line about setting these two equal one another. They wanted to know at what point will these two equal one another. So if you were to graph these two, where do these two functions, these production values, where do they cross paths? Where are they equal? All right, next one, number 2. A first number plus twice the second number is 9. Twice the first number plus the second totals 27. Find the numbers. So a first number plus twice a second number is 9. So we have two different numbers that we're talking about. So let's call x the first number, and we could call y the second number. So we'd say the first number plus twice the second number is 9, means equals. And then we have twice the first number, so 2x plus the second totals 27. So a first number plus twice the second number is 9. Twice the first number plus the second number totals 27. So there is our system of equations, and then we could just go about solving however you want to do it. You could use substitution. You could set up any set it up where you could do elimination. I'm just going to do substitution just because that's looking pretty straightforward. I'm going to subtract 2x from over here. So I'll have y equals 27 minus 2x, and then I'm going to substitute that into here. So I'll have x plus 2 times 27 minus 2x equals 9. Let's go ahead and solve this. I'm going to be pretty quick about the solving in this video, since this video is supposed to be just a focus on setting up these systems and making sure we know how to set these systems up and solve them from there. So we have 1 minus 4 is negative 3x, and then I'm going to subtract over the 54. So I have negative 45, divide by negative 3, x equals positive 15. So the first number is 15, then that means the second number, let's go ahead and just substitute that into there, y equals 27 minus 2 times 15, so 27 minus 30, which is going to give us negative 3. So the first number was 15, and the second number was negative 3. So the whole goal here with this video is to set up a system of equations, creating a system with x and y. And there are multiple ways of doing these problems. You could just do it where you set up in some cases you could just set up a single variable equation, but in some that might be a little bit difficult at times. So it might be easier to create a system. Next one, Thomas led the league in runs batted in for the 2019 regular season. Sammy, who came in second to Thomas, had 8 fewer runs batted in for the 2019 season. Together, these two players brought home 146 runs during the 2019 regular season. How many runs batted in were accounted for by each player? So we have two players. Let's call Thomas our X, and let's call Y Sammy. Okay. So the information they give us is that Sammy had 8 fewer runs batted in, so 8 fewer RBIs than Thomas. Sammy got second to Thomas. So we can say Sammy, which is Y, is Thomas's amount minus 8, right? Because it says 8 fewer runs than Thomas, because Sammy got second. So whatever Thomas had, which is X, Sammy had X minus 8. Okay. Together, these two players brought in 146 runs. So if we put them together, Thomas's RBIs plus Sammy's RBIs, we will get a total of 146. There's our system. So Sammy was Y, and Sammy has 8 fewer RBIs than Thomas. And then together, X plus Y, they make up 146 RBIs. So we have Y equals X minus 8. So let's go ahead and substitute in Y. So X plus X minus 8 equals 146. X plus X is 2X minus 8. And again, I'm going to be pretty quick about the solving because there's a lot of problems that I want to get through in this video here. So 2X equals 146 plus 8 is 154. Divided by 2. X equals 77, right? Yeah, 77. So that's Thomas's amount. Thomas batted in 77. And then that means Sammy hit in 77 minus 8, which is going to be 69. So Thomas led with 77, and then Sammy got 69. There you go. So nice equation, system of equations there. Nothing too complicated. The tough part here is making sure you're able to identify both an X and a Y. So that's why I just labeled X for Thomas, Y for Sammy. Next one. Watson has been pricing train fares for a group trip to New York. 3 adults and 4 children must pay $73. 2 adults and 3 children must pay $52. Find the price of the adult ticket and the price of a child's ticket. So again, we have two different scenarios. We have, let's call X being the adults, and let's call Y the children. So 3 adults and 4 children must pay $73, and then 2 adults and 3 children must pay $52. So they're giving us like 2 different pieces of information, like they're giving us 2 different scenarios that a group of 3 adults and 4 children pay this amount, 2 adults and 3 children pay that amount. So now we're trying to just like condense that down into a system to understand, well, what is a single adult or a single child going to pay? So we have the first scenario, 3 adults, so 3 times X, plus 4 children, so 4 times Y, is equal to 73. And then the second scenario, we have 2 adults plus 3 children paying $52. There's our system. There it is. So now we can just solve this. I think elimination is probably the easiest route. I think substitution is going to get a little bit messy because we're going to have to divide by 3 and everything, or divide by 2, or it's going to be 3 over 2. It's going to be a little bit complicated, so let's just go with elimination. I'm going to multiply this equation by 2, multiply this equation by 3 to make the x's the same. So distribute the 2, I'm going to distribute the 3 here. So this is going to be 6x plus 8y equals, I do not want to make any sort of errors here, 146. 6x on the bottom plus 9y equals 52 times 3, should be 156, yep, 156. Now we have the same x's, so I'm going to subtract here. 6 minus 6 is 0, 8 minus 9 is negative 1y, equals 146 minus 156 is negative 10. And then that's going to give us y equals positive 10, because we just divide by negative 1. So we get y equals positive 10. Let's go ahead and get x, substitute it pretty much into anywhere. I'm just going to go with the blue line at the top there. So 3x plus 4y equals 73. I'm going to substitute in 10. So 3x plus 4 times 10 equals 73. So 3x plus 40 equals 73. It's 40, so 3x equals 33. Divide by 3, x equals 11. So that means the adult is going to pay $11 and the child is going to pay $10. Nice $1 discount. One less dollar for the child. Okay, moving on. So these first couple problems, 1 through 4, not the most complicated, not easy, but not the most complicated. Like, I think it's a little bit clear. It's clearer what the x, what the y is, than these next couple problems that we're going to do, because the next couple problems are involving distance formulas or mixture scenarios, so we have to kind of be aware of some formulas here. So in number 5, we have Sherlock often flies from London to Berlin, a distance of 864 miles. On a particular trip, they fly into the wind, and the flight takes 2 hours. The return trip, the wind behind them, only takes 1.5 hours. If the wind speed is the same on each trip, find the speed of the wind and the speed of the plane in still air. So we have this scenario where we're flying, we have distance equals rate times time. And I know you'd be thinking, well, can we just set up some sort of equation with a single variable? Yeah, probably, maybe. But let's try to set up a system. So we are going with the wind in one scenario, and we are going against the wind in another scenario. I'm going to call it into the wind. So this is with, come on, erase. And this is into, so we're going against the wind in another scenario. All right, now it says the flights, they fly into the wind, the flight takes 2 hours. So into the wind took 2 hours, with the wind took 1.5 hours. And then we're given distance is 864, and that's gonna be the same for both, because one scenario we're going with the wind, the distance isn't going to change. Scenario against the wind, distance isn't going to change. So our distance is 864. Now our rate with the wind, let's say x is the plane, and let's call y the wind, because we have wind playing a factor here. Wind's going to help us out, and wind's going to slow us down, depending on which direction we're heading. So if I'm going with the wind, I am traveling at my rate of the plane, but I'm being helped by wind. So I'm adding on that wind speed. I'm being pushed forward with the wind. Now going into the wind, I'm traveling at my rate, but then the wind is slowing me down. So I'm going to subtract y for going into the wind. So with the wind is helping us. Against the wind, it's slowing us down. There is our setup right there. So we could say 1.5 times x plus y is equal to 864. And then we could say 2 times x minus y equals 864 also. Because the rate times time is equal to distance. Distance equals rate times time. So I said the rate, x plus y, times the time, 1.5, is equal to the total distance. Same thing with the other rate, x minus y times 2 equals 864. And the reason I'm putting this in parentheses, like, and I'm not distributing just yet, is because we can kind of condense this down a little bit. Like right here, since this is 2 times x minus y, I'm going to divide that by 2. So 1.5 times x plus y equals 864. And you don't have to write this out like this. I'm just kind of condensing this a little bit. 864 divided by 2 is 432. So this is x minus y equals 432. And since I did that, since that's divisible by 2, 864, it makes it a little bit easier because now I could just use substitution rather than worrying about like trying to wipe out that 1.5. So I'm going to do two things right here in my next step. I'm going to first distribute the 1.5, and then I'm also going to substitute in y, or I'm sorry, x, because I'm going to say x is equal to 432 plus y. Yeah, so a little bit of a system to solve here. So let's say 1.5 times x, which I'm going to call x, 432 plus y, plus 1.5 times y equals 864. So I distribute the 1.5 times x. I'm saying x is equal to 432 plus y. So I'll have to then distribute the 1.5 into there. But then I also did 1.5 times y, which I don't have any y value yet. So let's leave that alone. So then we do 432 times 1.5, which is 648, plus 1.5 times y plus 1.5 times y equals 864. And you could wipe out that 1.5 if you wanted to. Like, there's a way to do that. But if you want to try to avoid that kind of step, then I will just keep dealing with the decimals head on. Two things, I'm going to combine these together. 1.5 plus 1.5 is 3. Then I'm also going to subtract 648. So I get 3y equals 864 minus 648 is 216. Divide by 3, 72. So y is 72. Let's get x. So x is equal to 432 plus 72, which is 504. So what does this translate to? The plane speed is 504 and the wind speed is 72. I think these are all in miles per hour. So mph. Good problem there. Very, very good problem there. Tough problem. One of the tougher ones. But yeah, good problem. All right, so I'm going to break this into two parts. So I'm going to cut it off here.